morning friends, welcome back to our channel. Today we are going to learn about another important component in electronics.
Have you ever pressed the power button on your phone and wondered what actually makes this thing turn on? Or thought about how a microphone makes your small voice fill an entire hall? The secret hero behind both of these is something so tiny yet so powerful, the transistor. Now, let's start simple. Imagine you have a weak voice and you are trying to call a friend across a noisy street. No matter how loud you try, they just can't hear you. But if you had a loudspeaker, your soft voice would be enough. The speaker would amplify it and your friend would hear you clearly. That's exactly what a transistor does. It takes a small signal and makes it powerful enough to be useful. But wait, that's not all. A transistor is also like a switch. Think about a simple light switch in your room. You flip it on, current flows and the bulb glows. Flip it off, the current stops. A transistor does the same thing, but in a much faster, much smaller way. In fact, billions of tiny transistors inside your computer switch on and off in a microseconds, and that's how your app, videos and games actually run. Pretty amazing, right? Now let's look at the types of transistors. There are two main families, BJTs and FETs. BJTs, bipolar junction transistors, are like the hard-working old-school champions. They use both electrons and holes to carry current and are great for amplification. Then there are FETs, field effect transistors, the more modern gatekeepers. They control current with an electric field and are perfect for digital circuits. So whether it is a BJT or FET, the idea is the same. A small input controls a big output. But how does this magic happen? Let's take a BJT, the classic one. It has three terminals, the emitter, the base and the collector. Think of the emitter as a water tank, the base as a tiny tap, and the collector as the big pipe leading out. By just turning the base tap slightly, you allow a huge amount of water from the emitter to rush through the collector. That's what makes a transistor so powerful. A little push at the base and a flood of current flows at the collector. If you are using a FET, the names are a bit different. Source, gate and drain. But the idea is the same. The gate is like a door handle, and with just a touch, you decide whether the flow between source and drain should happen or not. Now let's make it more practical. Imagine you are building a small circuit to light up an LED using a transistor. You put the emitter to ground, the collector to one leg of the LED and the other leg of the LED goes to positive through a resistor. Now here's the fun part. You feed a small current to the base. Suddenly the LED lights up. It feels like you have given the circuit a magic touch. And that's exactly the thrill of using transistors for the first time. But here's something important. With great power comes responsibility. Transistors are delicate little heroes. Connect them the wrong way and prove they are gone. That's why safety matters. Always check the data sheet before using one. Never push it beyond its voltage or current limits. And don't forget the resistor at the base or gate. It's like a safety belt that keeps your transistor alive. High power transistors can get hot, so sometimes they need a little metal friend called a heat sink to cool them down. And here's a tip. Some FETs are so sensitive to static electricity, even a spark from your finger can kill them, so handle them with care. Now you might be asking, why so much fuss over such a tiny part? Well, because transistors are literally everywhere. They amplify your voice in microphones, make speakers louder, and bring clarity to your ratio. They act as invisible switches inside phones, chargers, and power supplies. They generate signals in communication towers. They control motors in robots and industrial machines. And the most incredible application, your computer's brain, the CPU, is nothing but billions of transistors switching on and off at lightning speed. Without them, there would be no internet, no smartphones, no modern life as we know it. So, next time you press play on a video or start a video call, remember it is not just technology at work. It's millions and billions of tiny transistors silently doing their job, flipping on and off like an orchestra of microscopic switches, creating the digital symphony of your world. To wrap it up, the transistor is more than just a component. Is the unsung hero of the modern electronics, small in size but massive in impact. It amplifies it, switches, it protects, and above all, it powers the digital age. Thank you for watching. If you enjoyed learning about the mighty transistor, don't forget to like this video, share it with your friends, and subscribe for more simple and fun electronic lessons. Until next time, keep exploring, keep experimenting, and let the current keep flowing.